So this is number 48 from chapter 10, and it says rank the following gases from least dense to most dense at 1 atmosphere, 298 Kelvin. And then they give us 3 gases right here. So I've got these gases written out right here. And then if you've been following along with our use of the PV equals nRT ideal gas law equation, you know that you can substitute in here mass over molar mass and then solve it for mass divided by volume, which ends up with the density for a gas equation. And density is equal to MP divided by RT. And so MP stands for molar mass times pressure divided by R, the universal gas constant, times T. And so, as you can see from this equation, density is directly proportional to molar mass as long as pressure and temperature remain the same. And you can see that each of them have the same pressure and the same temperature. And so really what you want to know density is the molar mass. The larger the molar mass, the more dense it's going to be. So we have to add up those molar masses on the periodic table. And for carbon dioxide, carbon is 12, oxygen 16 times 2, which is 44 grams per mole. Hydrogen bromide, hydrogen's 1 and bromine's 80, so that gives us 81. And then sulfur is 32 and oxygen 16 times 2, so that adds up to 64. Sorry, I was just getting the periodic table here to show you where I got those numbers. So in case you're wondering, sulfur right here is 32, oxygen 16, bromine right here, this is where I got it, is 80, and then carbon and oxygen right here, 12, and then oxygen's obviously 16 right there. So that's where you get those molar masses. So directly proportional to their molar masses, so this would be the least dense gas. So CO2 would be the least, and then our middle one would be SO2, and then our most dense one would be the hydrogen bromide gas. So this would be our most dense, our second most dense, and our least dense right here.